Hey guys, welcome to my tutorial video. Today we are going to be solving an integral equation. You might be thinking there's no reason to actually be doing this, but it's kind of funny to just randomly post this, and also I need to practice because I have a test, and this is also a really easy problem, as we will see. I don't know how to use this drawing tablet. Okay, so first thing we can notice is that this integral is a definite integral, which is quite convenient. That means we can just call it c, constant c. So phi of s equals s2 plus, my handwriting's so bad, bro, s2 plus s3 times c, or you can even write that a little bit better, just cs3. Okay, great. So now we have phi of s, and we can substitute it back into our integral. Okay, so I'll just do that here. Make that 1, -1. I have no script for this, by the way, so I'm probably like explaining this terribly, but you don't understand it anyways, because literally, why would you? Arctangent t dt. Okay, so as you can see, we've just, that needs to have a c there too. Whoopsie. I don't know where the eraser button is on this drawing app, so I kind of just freeball and just change my marker to white. So as you can see, we have substituted this here, except those s's need to be t's. I do this so much. I don't know why, because you would think I would just know to make it t's, you know? But yeah, so t squared plus c times t3 times arctangent t dt. Okay, wonderful. So now we need to talk about even and odd functions. Okay, so an even function is when f of x equals to f of negative x. Okay, so an example of an even function would be, say, y equals x squared, right? Okay, this is the positive side of y equals x squared. Sorry, that drawing's really bad. And this is the negative side. Say this is like -1 and 1, just for example. You can see that this point and this point are the same in terms of y, where this point is, we'll just call it 1, 2, and this one is -1, 2. So that's an even function. Awesome. An odd function, a good example for one of those, could be y equals x cubed. Why not? Why are you watching this? So we just draw that, and oh my goodness, that's actually kind of peak. Anyways, so you can call this 1 and this -1 on the x-axis, and we can say that this point is 1, 2, and this point is -1, -2. Why did it go white? I don't even... -2. Okay, so that's an example of an even and an odd function. So, given these examples, we know that t squared is an even function, as I just described, except it was x instead of t. And t cubed, or even ct cubed, the constant doesn't affect it, is an odd function. So, what about arctangent? Does it happen to be an even and odd function? Well, it actually does. How do I know that? Well, ChatGPT told me. But it is. Arctangent t is also odd. And I guess probably equal signs isn't the best here, but whatever, that's what I did. So, fun thing about even and odd functions is they're kind of intuitive when you how it works when you multiply them together. So an even times an odd function equals odd. Okay, even times even equals even, of course. And odd times odd equals even. Now this one might be a little weird because, you know, multiplication with numbers, odd times odd is usually just an odd number, but don't think about that too hard. So, another thing you need to know. Notice how this negative number and this positive number could both be represented as like a negative a, where a is 1, right? When you're integrating an odd function, you will always get 0 if you are, say, negative a, positive a, call this an odd function. That'll always equal 0. And of course, 0 doesn't really matter when it comes to literally anything. Amazing. So, let's multiply some of these functions together for the same integral. Negative 1 and 1. Okay. We'll do t squared times arctangent first. So, t squared arctangent t. I'm realizing now I really shouldn't have something that, like, as I press harder, it makes a bigger stroke. But whatever. And you're not watching this video, I promise. dt. Of course, this is an even function times an odd function, which is an odd function, so this will equal 0. Okay, so we actually don't even need this part of the integral. We can even mark it off here. Actually, I'll do it in a fun, different color. Exhilarating. So, what about t cubed arctangent 3? You might have already figured it out. But this is not 0 because it's an odd function times an odd function. This is odd, and this is odd. Amazing. So, I have a really nice calculator that'll do this integral for me, and I can go ahead and tell you the answer is 1/3. Okay? This would be a by parts integral. I'm not doing all that, because look, I don't have any room left anyways. So amazing. But you know what? I missed the constant, and we can just put that constant on the outside and call this entire integral I. Okay? This entire integral is also c, because, of course, as you can see there. So, this c being multiplied here times this integral, and this c equaling this integral, shows us that c is equal to c times I. And you can actually manipulate this equation to say c minus ci equals 0. That makes sense, right? You know, subtract something by itself, you'll get 0 always. Okay? So now, the reason we're doing this is we want to solve for c. Because as we know, phi of s equals s squared plus cs3. Okay? So when we get the c, we're done. We've solved the equation. Amazing. Okay? And we know that I is 1/3 here from this. There's a multiplied c here, so we can do that. And we can call this ci. So now I can kind of solve this, right? Let's factor out c here to get 1 minus 1/3 equals 0. Of course, this just comes out to 2/3, so c must be 0. Okay. So, going back to our original equation, we get s squared plus cs3, but c is 0. So, the answer to our integral equation is phi of s equals s squared. Now, you may know, if you know me well, that I want to be a teacher one day. That's not why I recorded this video. I wanted to see if anyone would waste their time and actually watch this. So, before you go commenting, wow, you're a terrible teacher, I hope you never teach, because you're just absolutely awful at it. I can let you know, if I were ever going to teach something, which I have before, I would prep a lot more than I did for this, because I realized a lot of mistakes I did going through here. I didn't even read the equation to you. I didn't explain like any of this stuff. You don't even know what an integral is, but of course you don't. You're probably like 5 years old if you're watching this. Actually, why are you watching this if you're 5 years old? I don't know who you are if you're watching this, but like, why? So anyways, yeah, I don't think I'm a bad teacher, but this is probably not a good representation of that. So, okay, we hit the 10-minute mark. So this goes big, I'll make some money off of it.